Good day, class. My name is Kim McCarthy, and I've been instructing for about 3 years or so, I'd say. A lot of times I have students look at me and say, "Why'd you ever choose ironwork? Women don't do ironwork." And I always reply, "I never. It chose me." You see, we are not always on the path we need to be on, and I wasn't. So my father, the ironworker, dragged me to his union hall and signed me up for the apprenticeship program. So here I am teaching it. Wow. I've come full circle and very happy to be standing here in front of you guys today. Having said that, today we're going to start and discuss structural steel components. And we're also going to discuss some safety aspects, such as the hazards that accompany this type of work. So let's have a look at the outline. So if you'd have a look here at our outline that we're going to take part in our course today. Just having a quick glance here, you'll see a lot of different terms and stuff that a lot of people are probably not familiar with. Some of you might know a little bit about it, but I'm assuming that not everyone understands these terms that I've got written here in this outline. I'm hoping by the end of the course you guys will have acquired some knowledge and understanding, and these components will be easy for you to identify and understand where they play a role in structural steel. Looking here, we got columns, beam and column connections. So right off the hop, we're going to see beam and columns connect in some manner. We got a channel, we got a structural T, and we'll keep on going down through steel joists, purlins, decking. All of these are steel components which make up a building or a structure in which we build as ironworkers. At the end of this, we'll actually during the course we'll do a in-class practical, and then at the end or towards the end we will go down to our shop and go outside in our yard where we're going to look at some steel components, and you guys are going to do a practical for me. So it's going to be a great opportunity for you guys to learn this material and get some hands-on. I'm looking forward to going through this course with you guys. So on this slide here, you're going to see some topics that will be discussed during this course. You're going to see the various steel components which make up a steel structure. You're going to know their characteristics associated with that steel component. You're also going to have to identify these components by using mark numbers, which you will find on a blueprint. We're definitely going to look into the hazards associated with ironwork. Ironwork can be a very dangerous trade, and safety is always on the forefront of the mind all times, every day, from the time you strap your work boots on until you go home take off your work boots. Safety is a big thing in industry now, and as we teach you guys, we want to make sure we drive home all the safety aspects that you guys need to know and to be able to bring to the job. So that's a big objective there that I'm going to really enforce. We're going to introduce then how steel connects. So how does it connect? It's great to know steel components, but just knowing them as separate pieces, it's hard to understand how they actually make a building. So we'll look a little into that, but we're going to get further into that into our next steel erection course that you guys are going to do. Good morning, class. Welcome to Structural Steel Components. Today we're going to discuss the different components that we need to know to erect structural steel. There's many components obviously involved in building such a building as here is on this slide. We will see and talk about their differences, the different steel components, and some similar characteristics these steel members may have. Also, we're going to look at their applications of the steel components, along with some knowledge in blueprint reading. So we'll look a little bit at blueprint reading, but we're actually going to do a blueprint reading course later on in this year. So we'll just kind of touch on it for this component of our of our course. The practical, we will bring you to a shop setting, so we're going to go outside actually, where we're going to identify these steel components by characteristics, and we're going to look at the mark numbers that you're going to look at on the blueprint and match up with the steel itself. So this is going to be a great course to make you guys familiar and know the differences and be able to identify them. So here's our first structural steel member that you guys are going to look at. Here's our column. Our column is a vertical steel member. So as you see here, it stands upright. It transfers the load to the ground. So it's going to bear all the weight of the building, and it's going to transfer all that weight directly to the ground. Here are some anchor bolts in the picture here if you want to have a look. Normally there's 4 anchor bolts. There could be more, but pretty typical there's 4. They have to match that base plate there when we go to connect that column. That column has to be plumb, which means at a 90-degree angle to that concrete pier at all times. If it isn't plumb, we got to make it plumb. So in our erection steel course, we will figure all that out. But right now, that has to sit nice and plumb and vertical for that column to work in our steel structure. So the first structural steel member, which is erected in a steel building, is the column. This has to be rigged properly so that the column hangs vertical and plumb. A shackle and a wire sling or bull tail, which would be one shorter choker, choked to the column, and a longer choker hooked above the ball of the crane. The base plate at the bottom has to correspond to the anchor bolt pattern that's preset in the concrete pier. Then the column is to be positioned so the holes in the base plate match the anchor bolts. In this picture, it's hard to tell the shape of a column as it's hanging vertical, but if you were to take a beam and put it on its side, take this column and put it on its side, it would look like a beam. And we're going to look at a beam next. So when we look at the beam next, you'll get a better idea of how that column looks as if you were on top of that column looking down. You'll be able to see the actual steel structure of that column. Why do you think it's important that the column hangs vertical and plumb? Just give you a second now to think about that. Yes, absolutely. The building will start to lean if that column isn't plumb. And we want it to sit vertical and plumb. It's not pleasing to the eye when something leans, unless it's the Leaning Tower of Pisa, which everyone, I'm sure, is well aware of. But we don't want that in our structures. We want them sitting nice and plumb and level. Right, so when we go connecting our steel, if our column isn't plumb, none of our connections are going to match up. Everything's going to be, it's going to throw the whole structure off. Our holes are going to be off. Any welding we got to do is going to be off. It's going to leave big gaps. So right from the get-go, we got to make sure she's nice and plumb for us to start our steel structure. Great job, guys. All right, guys, so let's have a little safety moment now. We just discussed columns, and we gotta be aware. So it says safety first. Be aware of crush points, not pinch points, crush points. Where are the crush points when installing and erecting columns, do you think? You got to concentrate on hand and feet placement for sure. We are using our hands and feet as we're placing those columns, absolutely. They're easy to crush, and they're usually in places they shouldn't be. It's important that we have proper hand signaling. So when we're erecting those columns, we got someone giving proper hand signals so that that column is coming down where there's no hands or feet. So our signal person is watching where that column is being placed and are very aware of the workers that are helping install and connect that column. You guys got any other suggestions? Yeah, so when erecting columns, safety is at the forefront of your mind at all times because we know accidents can happen so quick. The column could easily crush a worker if the rigging lets go or the crane fails. Because should we really put all our trust in machinery and hydraulics? No, they fail, unfortunately. So we got to be well aware of that and do not trust them. You always keep your body away from the load and guide the steel column by using tag lines. So we use those tag lines so that our hands don't always have to be on the steel itself. Once you got that directly above the base plate, the column, you lower the column down over the anchor bolts with all your body parts away from the line of fire. And we always have a look at our buddy while we're doing this and making sure as that column is coming down, we're having a look at ourselves, but we're also peeking over at our buddy next to us and making sure that they're remembering too, because if not, we're going to give them a good reminder so that they don't end up crushed. You got that signal person there designated that's signaling the crane, and they're also keeping an eye out. So a lot of teamwork's involved when we're doing this job, and we got to remember that. We always keep safety right at the front of our mind at all times. There's no hurry up and get it done. We take our time and do it right and do it safe. Bottom line. So look here now, guys. We have a beam. Quite the opposite of a column. This one here sits horizontally, whereas a column sits vertically. And I'll get a lot of students at times call column beams and beams columns, and actually I'll stop them dead in their tracks. I'm like, now think back. What way does a beam go? What way does a column go? And usually when they think about it, they give me the right answer. But I want you guys right from the start to figure out a column sits vertical and a beam sits horizontal. You can get an American Standard I-beam or you can get a wide flange beam, and we'll discuss that a little bit later. We also have intermediate beams, so they're lighter beams, smaller beams, and you'll see them used in different places in a building. You'll see them used as filler beams in the center of the structure. In places over doors, over windows, beams will be used as headers. So they're very versatile piece of steel, and they're used throughout the structure. So let's talk about the beam for a little bit. Beams are rolled in stock lengths of 40 feet. They can be cut in the field or they can be cut in the shop, whatever's required that the company is looking for. And as we discussed, they can be classified as an American Standard I-beam. Why do you think it's being called a Standard I-beam? Yeah, it looks like a capital I, so that's pretty simple, hey? You can see the letter I there. They have a sharp slope on the inside face of the flange. So if you look at that slide there, the very top of that steel, that's a flange. The middle, we'll call that a web. The bottom of that beam, we'll call that a flange. So we have a top flange, a web in the center, and then a bottom flange. So that's how that is labeled, right, if you were to look at the beam and as we're talking about it. The I-beam can be designated with an I or an S. You'll see on a drawing, you'll have an I in front of it or an S in front of it. The depth is always exact as it's designated. So if it's telling you how deep that beam is, if it's saying 12 inches, that is exactly 12 inches. The wide flange beam, which is another type of beam, that can be used as a beam or a column, depending on its application. And you'll see that on the print written as a H, a B, a CB, and even a WF for wide flange, which makes much sense to call it a WF. Now, this one has a nominal depth for designation. So I want you guys to write this down for me for a second and we'll discuss it a little bit. I want you to write on the sheet of paper there, 12-inch, capital W, capital F, which is a WF for wide flange, and then 85. So let's look at that 12-inch first. That 12-inch is not exactly 12-inch. That's a nominal number given to that designation. So that 12 could actually mean 12.19 inches. It's always off just a little bit. It could be, right? The 85 that you see that you got written down in front of you, that's 85 pounds per foot. So for every foot of that beam, it's going to weigh 85 pounds. The WF, that's wide flange, which we just discussed, the different designations that you can see on a print. The beam, being the horizontal member, plays the role of tying or connecting the columns together, usually in a box pattern. So normally you'll see 4 columns and 4 beams, which would be like the shell of a building. So you got your 4 columns, 4 beams, and that would be a boxed in steel. So let's have a safety moment again now. We just discussed beams a little bit. Here we see rigging and slinging requires knowledge and safety. So not anyone can do some rigging and slinging. You got to have some knowledge behind you. You got to learn the theory behind it, and you got to be safe when you're doing it. So what kind of things can we consider when we're rigging beams? We got to have proper slings, and there's many different slings we can choose from, but we got to have the proper sling. We got to have the proper tool for the job, as we would say, as a cliche. We got to know the weights of those beams. So we don't know the weight, we don't know which is the proper sling to put on to carry that weight. So we got to definitely know the weight of the beam. Inspections of those slings are also very important. During the inspection, we're going to find anything that could cause that sling to possibly break or bust, which would mean we would have to take it out of service. And if it passes inspection, we're good to go. Always important to do those inspections. So as a recap, the proper and safe rigging of these steel components is very important to ensure safety of the workers. So the safety of the workers is very, very important. That is our most important job when we're working, is to keep everyone safe and to keep ourselves safe. We got to consider that thorough inspection of our rigging equipment. We got to properly select the rigging that's required, and we got to know how to put that rigging on. So we got to be able to apply that rigging to our beam so that it's going to be able to be lifted by a crane properly and not fall off or hurt somebody. We're going to discuss rigging a little further on in our ironworker course, but for now it's just a little introduction on how important rigging and slinging is of beams and other structural steel components. So here we got some of those intermediate beams we just mentioned when we were talking about the wide flange and the I-beam. We got light beams, junior beams, miscellaneous beams. These are usually your filler beams. So a lot of the interior of the building will be filled in with these smaller, lighter beams. And you'll see that as you look at the print. You'll see the requirements that are on the print there. Some of these lighter beams will be our interior of our building. These are mostly used as intermediate steel, filling in areas where more load bearing is required. Where heavier beams can't fit, we'll put these smaller beams in that can be used. And you'll see them above, you see them in the framing above windows and door openings. So they're great little beams for the interior of the building. So looking at the light beams there, they're designated by a B. They're light in weight, and that's how they're usually designated, such as 6B, 12.6 inches. So that'd be a 6-inch light beam weighing 12 pounds per foot. You got your junior beams, which are extremely light beams, and they are designated by a capital J, a capital R. Again, there's an example, as we see in the light beams above. Miscellaneous beams. They're designated with an M. They're similar to the light beam, but their application may be a little different. So far, we've looked at beams and columns, and we discussed what they look like and what their application is. Here you can see in this slide here how they connect. As you can see, the columns are vertical and the beams are horizontal. Here's where the structure starts to take shape. So you're starting to see a building give birth here, basically, or be born. As I mentioned earlier, the beam and column connection will be the basis of the main structure. The building begins with 4 beams and 4 columns called a boxed-in steel frame. It is the shape of a box. Pretty basic, hey? The connections are bolted together as in the picture you see right here, guys. A connection plate may be used to aid in the connection of the 2 pieces, and you can see the connection plate there. The connector, known as the ironworker connector, has to stand on the steel, be brought to that elevation by an aerial work platform, and they are always 100% tied off, as in per regulation of our act and regulations under fall protection. Here, those guys are going to align the steel and insert bolts into those holes, connecting the beam to column via proper bolt pattern. This can take a lot of work. Sometimes those holes don't like to match up, but us as iron workers, we got the tools to align those holes so we can put those bolts through and connect. The connecting part of steel, that's a specialized part of ironwork, and it takes a lot of courage for those people to get up at that height and pretty much hang from their toenails to connect that steel. But as ironworkers, we love it, and it's part of the job. It got to get done. So you guys are going to have a chance actually at the end of your apprenticeship course, or towards the end, guys are going to start putting up a steel structure, and you're going to have some practice at this. So if you guys really like the connecting aspect of it, you can further your career in that part for sure. But yeah, so this is a big part of our job as an iron worker. And it's important to do it safely. Again, as I say, I keep bringing up safety, but safety is so important. We got our fall protection to keep us safe, and if we use it properly, it will keep us safe. But in Newfoundland, unfortunately, falls are a very big killer in the industry, and we got to be aware of fall hazards at all times. So let's move on to our next structural steel member. Here we got the American Standard Channel. Just have a look at it. What shape does it look like? Yeah. C-shaped is the key words here when identifying this steel member. It resembles the letter C. These can be used as purlins and girts. So girts are used in the wall of a structural building. So let's just pretend we tip that channel forward with 2 legs facing down like a table. We'll see that's how the girt will connect and sit in the wall. It's there to stiffen the walls, and then you connect sag rods through those girts, and those will help prevent sag in the walls of that building. The purlins, on the other hand, they're found in the roof, and that's where decking is connected to. These will hold the roof section, so if you let the channel sit and connect as it looks in the picture, right there, guys, in front of you, that will resemble a purlin as it sits on a roof. That can also come, besides a C, it can also come in a Z shape, and I'll show you a little further into this course what that looks like. So we don't need to look too further. Here's your purlins. So you got a C shape and a Z shape. So they can come in either or, and they're using the roof. So see where those holes sit? There's going to be sag rods also go through here, so it's going to keep everything nice and straight and not prevent any sag in that roof that we're gonna build. So that's where the C channel comes in there in the C shape, and then we have the Z shape, and these are known as purlins. Next we have the structural T. If you were to flip this one upside down, you would have a T. It is easily recognized because of this. something like the I-beam looks like an I. The channel looks like a C. The T, structural T, looks like a T. So these are some good pointers on how to identify the steel when we got something we can refer it to. These guys are used in reinforcement of steel. So when there's a heavier load bearing applied in a building, such as heavy machinery placed on certain portions of a floor, or a heavier congested area of people are gonna be at different times in that building, that's where a lot of the weight will sit, and we'll need to beef that up, and we'll need to use sometimes these structural Ts, which is also called a stiffener, because they're going to stiffen up that structure and they're going to help with the weight that's going to be applied there. These can be easily made by either by two plates welded together on the job or rolled in a shop by cutting the top flange off an I-beam. These are very versatile components in ironwork, and you'll see them used in different applications. So who can guess what letter this one looks like? An L, right? Angles. Looks like an L. They consist of two legs. They can be equal or unequal width, and they're set at right angles to each other. Often the most misspelled word on social media, angles mistaken for angels, or angels mistaken for angles. Easy word to misspell. I just thought I'd put that in there. I thought it was quite funny. When I was trying to actually type this one up, that's what came to mind. Making sure I spelled angles instead of angels. Also, these are somewhat like the T's. They can be used as stiffeners. The angle you can find almost anywhere in a structural steel building, from the base angle, which holds the siding on the walls, and also angle bracing in the walls. The roof, it helps with the connecting of the decking. It is probably the most versatile steel component, easy to handle, can be placed anywhere because of its size and shape. And like I said, they're great stiffeners, they're great fillers. They are used quite often if we are making up any other type of steel component. They can be welded together, bolted together. They are a great steel component in building a building, and can, like I said, can be used basically anywhere in that steel structure. So have a look at this picture here. What do you see besides that beam there? Right, angles. So here's our angles at work. They serve as a bracing to stiffen the steel structure when they're used as bracing in this manner. The two pieces of angle iron back to back, if you have a look there, they're bolted together there in the picture. So they're assembled so that they serve as a bracing. And there's a connection plate there where those bracing sit. It holds the bracing in place and serves as a permanent bracing, which helps stabilize the building and prevents any side loading and shifting in the building. It keeps the structure plumb and level. Here we go again, plumb and level. We got to keep that structure plumb and level so she looks pleasing to the eye, and all our connections are going to fit properly together. And that's our angle at work, which is great when we're doing our steel building. Next structural steel member we got is a steel plate. And as you look here on the slide, it looks like plate. We got two different types, as you can see in the picture there. Very versatile steel for iron workers to work with. All different shapes we have seen so far in my slide here that we looked at are different structural components. They can be rolled from steel plate. It can come as a raw material, like you see right here. It's a great asset to any job because sometimes steel components need to be fabricated on site. It's great to have lots of plate on site. And then the checker plate that you see there in the top left corner, that's for basically providing grip. So if we were to do a floor or a set of stairs or a walkway, we're going to use that checker plate. And again, going back to the safety aspect, we don't want anyone tripping and falling in that building once we're making it or while we're erecting it. So we can use checker plate in highly used walkways and stairways to keep people from slipping. We will put that there, and it's great for that reason. Always, again, safety is always first, because when we have accidents on the job, if you want to think of it that way, insurance costs go up for those companies, and a lot of times those companies can't pay the insurance bills, so for the next job they mightn't get the job, which means if they don't have work, we don't have work. So being safe is an absolute, you have to be safe, because we need the work, and the work has to be done safely, and besides that, we don't want to be hurt. Now we're going back to the top of the building. We got steel joists here. These are connected to our top beams, and they will support the roof structure. You're going to see some bridging, which is going to be welded in between each joist, top and bottom core, to stiffen and stabilize the joists. So if you just look here at the very top, that'll be our top chord, and then we come down to the very bottom there, that's going to be our bottom chord. So if you just picture one sitting next to the other, there's going to be a bar going between each one every so many feet, and that's going to be a bridging that's going to keep those connected on the top part of our structure. And these guys will run the whole length of the building every so many feet according to our blueprint. So when we look at our blueprint, we see how our steel joists are going to be laid out. So this is just another steel structure. It looks a little different from what of the steel structures we've previously looked at. And this will be found in our roof. So it's part of the roof steel. So next we got decking. If you think of those steel joists we just looked at, this decking is going to sit on top of those steel joists. This can be used in the roof, but also in our different floor sections you will see decking. Each level will get decked off. Unfortunately, though guys, this is when iron workers get a false sense of security when this decking is laid. The decking makes you think it's safe to walk around and not tie off with fall protection, which is a big no-no for iron workers and any other trades that are now on the roof doing their work. There's usually hole openings when we have decking laid down, and sometimes decking is not welded. So then there's a big opportunity for falls to happen, unfortunately. Also, workers on decking have been thrown off buildings. Sometimes that decking, when you're laying it down and you're starting to lift it up, it acts as a sail if the wind gets underneath, and it can take someone right off a building. So you got to remember, special care and attention is required when erecting decking, or laying. We call it laying down, actually, laying down decking. Journeyman will help with having lots of prior experience and knowledge when you're doing this decking, because like I said, a lot of care and safety got to be taken. How can we be safer, do you think, when erecting and working with decking? So what kind of things comes to mind? First off, yeah, we got a buddy system. So never handle that decking by yourself. Second, never leave open holes unless they're labeled and a physical barrier is around them. If we got something there telling us a hole and there's a physical barrier where we can't get through, we're not going to fall. Never work in high winds. And always, guys, always exercise your right to refuse unsafe work. So if you feel it's too unsafe, too windy to lay that decking, you make sure you exercise that right. Always assess your work area, and never rush. Never rush with this stuff. You've got to take your time and do it properly and do it safely. Always keep good housekeeping when you're on that deck, because you can kick something off quicker than you realize. And we always follow the regulations and act for our fall protection. Always 100% tie off, and that's mostly required on decking. So keep all that in mind, and we shall be safe laying our decking. Here we got cladding, guys. Cladding goes on the wall, on the outside walls of our building. Is what encases our structure that we built. And it adds aesthetic look to the building, basically. So something like the siding on your house, if you want to think of it that way. It can come in a variety of colors, gauges, and different patterns according to the look that the architect is trying to achieve. Sometimes this can be mistaken for decking at first glance, if you just think back to the other slide. But if you look closer at cladding, if you had it right there in front of you, you can't really tell from this picture, but there's usually a layer of insulation, and you'll see a color. There'll be a color like brown, some type of gray, some different color than the decking, which is always that silver gray color. And like I said, just think about the siding on your house. You can get it in all different colors. That's pretty much the way cladding works also. Again, when working with cladding, you got to keep safety right at the front of your mind. This stuff can be pretty dangerous, something like decking, especially when it's a windy day. Always take precautions for sure when installing cladding. So guys, it's time for you guys to do some work. You're here listening to me talk now for the last 36 minutes or so. I want you to do this practical for me. So I'm going to give you this handout, but it's here on the front. I got it here on my slide just so you can have a quick glance at it. Here's a little outline of a structure with different steel components. I want everyone to get in groups of 2, and we're going to work on this drawing. So each steel member is labeled with a number, and I want you on a separate piece of paper to write what each number represents. I want both group members working together, but each writing your answers down on your own sheet of paper. I'm going to give you guys about 15 minutes or so to complete this, and I want to hear lots of discussion from your groups. I don't want one person doing all the work. I want you guys to take turns figuring out what each steel component is. And we'll have a discussion about it once you guys are done. So great job on that practical, guys. You guys did really well, and I guess you're learning something because you're starting to learn your steel components. Let's have a look for a moment at how these steel components connect. So if we look in our top left here, we got a welded connection, and if we look at our bottom left here, we got a bolted up connection. So if we're welding something, we're going to need a welder. So that connection there requires a welder. The bottom bolted up connection, we're going to have our connector align those bolts and put the bolts in where they are required for that connection. So basically you can have 2 types, and we will see that further on as we do the steel erection course. Either how that's to be welded or how that's to be bolted. We got to go by special requirements that are in our notes on our blueprints. So that's how we decide what way that connection goes. Mark numbers. So on our steel components, we're going to identify our steel components by a mark number. So a mark number is going to be a letter and a number. If we didn't have that on there, it would be a guessing game for people in laydowns and people who are connecting and people who are rigging. We got to know those mark numbers because according to our print, that's how those mark numbers are going to go and where we're going to place our steel. Also, mark numbers always go north. So if we are connecting, we're going to make sure those mark numbers are facing north. That's a good indicator to the connector on which way to place the steel that's coming at them. Let's have a look at our little print we're going to use when we go down to the shop, and we'll see we got some mark numbers on that print. Have a look up here, guys. Blueprint for identifying our steel. So this is just a little sketch of what we're going to use when we go down in our laydown to look for our pieces of steel that we're going to need to erect our building. And I want you guys to identify them so I know that you know what you're talking about and that you've learned something from this theory portion. So looking here, A1, A2, B1, B2. and we see like an eye next to them. That's going to be our columns, our 4 columns that we're going to look for. See the mark number A1? So as I said, you're going to have a letter and then you're going to have a number. So also we got beams. If you want to have a quick look here, we got C6, B6, D6, G5, and so on. So when we go down in the shop, we're going to look for those mark numbers and we're going to find our piece of steel that's required by our blueprint. And we're going to do a blueprint course. So this is a little, just a little sketch to help you guys identify. See that N at the top of that print with the arrow? That's going to be our construction north. So when we go to erect steel, that's everything's going to be facing north. Those mark numbers are going to go to the north. And that again is going to help us make sure we put our building together correctly and our steel is all connecting the way we want it to. I will also give you guys a copy of this when we go down to the shop. So no worries, you don't have to memorize that.
And so because we got all our theory up in class, we're going to come down here today and figure out what a beam looks like. We've seen on the PowerPoint what it looks like. Now we're going to put it to practical use. We're going to go find the beams that's required from this blueprint that we're actually going to build inside that building. So if you all want to gather around me, I'm going to have you have a look at this blueprint. So when you're looking at a blueprint, you'll always see N, construction north. Okay, so construction north for us is if we're inside that building and we're looking this way at the print. Okay, so north is coming out through those doors. The building that we're going to build is basically 4 columns. So 1, 2, 3, 4, and we're going to have 2 floors. Okay, the 2 floors are identical, but there's a couple differences. If you see here, A3 is for the first floor, and C3 is for the second floor. So that's going to be one difference in the first floor and the second floor. And I believe that must be the only difference in the building for the first and second floor. So what I want you guys to see here is what columns do we need put up in there. Let's have a look and see what columns are required. So we need, if you look here guys, come closer. We need an A1, a B1, a B2, and an A2. So what's the difference of a column and a beam? How do we tell the difference of this side?
You connect the columns.
Right, so beams are going horizontal from column to column, right? And where's the columns going?
Vertical.
They're going vertical, so they're anchored in with anchor bolts, and they're standing vertical for us to connect our beams into, right? So the first one I'd like you guys to find is, we got 4 to look for. A2, our B2, our A1, and our B1. So we'll have a look over here in our yard and see if we can point those out. Let's have a look. I want you to be very careful now, guys, because we've done a lot of trips. We just done our FLHA. What do we keep in mind when we're out here in the field? What kind of dangers do we have?
Tripping hazards.
Tripping hazards. What else? Pinch points. What about if you stand on the end of a beam and it's a slip up on your right and it's not nice and level under the joints? As we can see, there's joints everywhere. And a lot of men. So where are our columns to? I can see some right in front of me here now. Can someone point them out for me? Okay, so where do we look for our mark number on our column? Let's have a look here. So that's all right. Down here we got a A1, an A1. Okay.
So guys, today we've discussed structural steel components, and I believe we've met all our objectives. You guys done a great job at your practicals out in the field. You got some hands-on experience with the steel itself instead of just seeing it on paper and in front of your eyes. You actually got to touch it and see how it sits and everything. So you guys were able to, you're going to be able now to describe the difference between the different structural steels. A lot of times we can think of letters to help us identify those pieces of steel. So that's a good little hint there for you guys. We're going to know how to identify them by their mark numbers. We've done that out in the field, and we've done it here in the practical portion. Assessing the hazards, and we've stressed safety through this whole course, and I hope you guys remember the safety parts and you bring it to the job so that you guys will be able to do your work safely and go home the same way you went to work. And we're going to, every course that we're going to do, we're going to bring that home. Safety, safety, safety. We don't want to ever forget it, and we don't ever want to rush. We got to make sure we're always doing what we're supposed to be. Even when we're rushed by someone else or we're rushed by ourselves, we slow down and do our job properly. You guys are going to be able to analyze steel and see how it connects in a structure. We touched on it a little bit. We're going to further our knowledge as we go through this ironworker apprenticeship, but you guys got to touch on it in this course, and we will see it more in the next steel erection course. So I want to thank you guys for all your great input today, and you were great in all your practicals. You took part and done what you were supposed to do, and thank you so much for listening to me, and we'll get to do some more ironworking, I'm sure, as we go through the course.